All right. Hello, everybody, and welcome to the stream. Hope everybody is doing well today. We're doing a extra stream today, outside of the normal streaming hours, right? Just hopefully we can accomplish a few extra things. I don't know how long I'm going to run today, but we'll kind of play it by ear and see how we go. All right. So last time we sort of left off where we were doing a little bit of optimization on our terrains by changing from using a bunch of individual textures, texture samplers, to converting it to a sampler array. And as is required for that, we basically have to generate a layered texture, so to speak. And that's what we were in the process of doing on the last stream. And so today we're going to, at a minimum, tie that up, get that working. And then look at some other ways that we could maybe optimize the terrain. So, Smudge, hello. How are you doing? It's good to see you. Tripping over my words today, I see. I hope you're doing well. Welcome. So I did do a little bit of stuff offline, just kind of get some of the grunt work out of the way, so that we could kind of focus on a little bit more important things. But So I did go ahead and last time we were kind of discussing some different ways when we go to load or call the image loader to query properties of an image. We didn't really have a method of obtaining a base asset path for that, right? Because in our engine we really only refer to assets by name, not by path. And the reason that we do that is because that way we can actually, eventually with our underlying file system, we can have sort of an archive system that will ship, which is basically a huge binary blob that contains all of our assets. And so as a consequence of that, we needed to find a way to query that path for that resource type. So we've added this new resource system base path for type. And what this does is it reaches into the resource system, finds a loader for the given type, in this case an image, and returns the base asset path plus the specific type of asset path. And so in our case, that'll be like // assets and then / textures in this case. And so we go ahead and we obtain that, which incidentally, this does create a new string and return it, so we have to be sure to clean that up. I don't think I've done that yet. And then we run that through a string format where we figure out file extensions and figure out which version of that file exists, and then we go ahead and we go ahead and query that file. So this follows a very similar pattern to just loading an image in directly, and so I might wind up actually kind of condensing some of this code, some of the repeated parts, into like an internal function. But for now, they're just enough different. I just left it, separate instances of that, just to facilitate the process of getting this to work. So essentially, the other thing that I've done is at the top, we have this supported extensions, which is now sort of a private static array of strings. And these are the current extensions that we support within the image loader. When we switch to a binary format, this will essentially go away, and this will be moved over to whatever import process we have. But for now, this is kind of the way that we do it, right? So we look for Targa first, then PNG, then JPEG, then bitmap, right? And if we don't find any of those, then we say, hey, it's not found. Because for now, those are the only formats we're supporting. Okay, so with that, what we do is in both places now we can just loop through that sort of supported extensions so that we don't have to recreate it every time we query. So that's a little optimization there, and then we check to see if that file exists. So we basically try it with each extension along the way. And that's kind of where I left it off here, at least as far as off-camera work. So we're going to pick that up today and get that working, and then start setting up our actual loading over here as an array texture. So, Level Up Design, what's up, man? Good to see you. Welcome. Magetz, hello. welcome. Good to see you too. And Beat Watcher, hello. And also hello everybody over on the YouTube side. We are simulcasting, so I do watch both sides. So just for any of you guys that are new, this is an interactive stream. So if you guys have any questions or things you want to talk about that's semi-related to this, feel free to bring it up, right? All right. So with all that said, I did just mention a couple of things, and I actually noticed a couple of things as I was looking at this code that I need to address. So we get this base image path, and we essentially only, I believe, use it up until here, where we're building out the full file path. The full file path, we're just doing just a buffer of 512 characters. Anything over that, obviously, there will be a problem, but I don't think that'll be an issue, especially once we switch over to our system of having an archive file system, right? So, in that case, let's see, base image path, that could actually be destroyed here. So I'm going to say actually I'm going to say string free, I think it was. Yeah. And let's go ahead and free that image base path, just to make sure that we don't leak any memory there. Does this not take a constant? I guess it doesn't. All right, I mean, we don't really worry about that. It's just a warning, so I'm just going to do a hard cast on this. You normally shouldn't do this, but since we're freeing it, I'm not really that worried about it. Okay, so we clean that up. Let's see, our format string here is basically where we're building each file path with the extension. So we're taking in the image base path and then the image name and then the extension. So we only need 3 of these here. So we should have base path and then image name and then extension. So that should do it for that. We check to make sure that we actually found an image, and if we don't, we bleat about it and return. We go ahead and open the image, grab the file size from it. Gabriel, thank you so much for the follow. I appreciate that, and welcome. Ivoca, hello. Welcome. Let's see, I'm planning to abstract my graphics API, and I have to think about how to deal with the layout transitions with textures. Should textures track their own layout or something? I don't, personally. I leave that up to whatever's using it, in my case. Like, if I'm using it as an attachment, it's up to the attachment itself, not the texture. That's basically the way I handle it. Use switch instead of if else, yeah. Yeah, that's become a bit of a meme these days, right? From Lake, hello. I have a question. How was your day? My day's going pretty good. Can't complain. Matus, I hope I pronounced that correctly. Hello. And iDog, hello. Welcome. All right. So essentially what we do here is we try to read the whole file, make sure that we did that successfully. And then actually, from the time that we allocate this array here for the data to go into, if we fail at any point, we basically just do a goto to this guy down here, just to make sure that we don't leak that memory. So I think we should be okay. We're file system closing. Otherwise, I should probably come up with like an error handler for this that I just kind of pass the whole thing into. That handles this automatically, but for now, I'll leave it. So I think this actually should be good to go. So basically what we're doing here is we're just querying the properties of the image, and then, let's see, we do the read all. Did we actually add the query? We have the query in here as well. So I think this is actually good to go. I think this is done. Let's just write that. And then over here, actually I'm going to kill this other view here. When we are doing a texture system acquire textures as arrayed, we do a little bit of validation here. So we make sure that the layer count has at least one thing in it. Otherwise it makes no sense, right? And then we query the dimensions, right? So we grab the first width and first height is what we're calling it, because it's the first layer's width and height. And so we make a call out to that, make sure it's successful, just using the first texture name. And then once the image size is acquired, we basically figure out how much memory we need, right? So in this case, our layer channel count is always going to be 4, so RGBA. Our individual layer size, we'll need to know this, is basically the size of a U8 times the width times the height times the channel count. So that's how big each block of memory has to be for each layer. And that's sort of our layer stride, if you will. And then our image block, which is the entire block of memory, is basically layer size times layer count. So that ensures that we get a block of memory that's big enough to read all of these textures into. Yarbongos! Weird Trash Can, hello. How's it going? Welcome to the stream. Retro you, yes, a stream I don't have to watch at 3 a.m. Nice. Are we chunking terrain today? We might get to that. We are basically working on setting up array textures for terrain first. Just to reduce a little bit of the overhead and all the sampling we have to do with that. So we're pretty decently far along with this. So I think we might actually be able to get to that today, but we'll see. Okay. So, I think the thing that I'm going to do for now is, let's see, we have to load these images, right? Which I said before was, I do actually need this other tab open. So the image loader, does the image loader do this, or is the texture system that does it? I forget. I think this is just a synchronous process. Yeah, I don't think this actually uses the job system. So theoretically, we could just wrap a job around the entire thing, right? And that may be the way to go. So when we, let's see, when we acquire, a texture, we do a process texture reference, which we also are going to need to do. I'm trying to remember where I kick off the jobs for this, because it's been a while since I've looked at this code. So I'm just refreshing my memory, as well as for anybody that's sort of new to the stream. I guess you guys will be seeing this for the first time. So we check if we're incrementing or decrementing the references, which means whether or not we're releasing. Mohammed Aldel, thank you for the follow. I appreciate that. Glad for an earlier stream too. EU friendly hours. Yeah, I wish I could do this more often, but obviously I can't, right? So the struggles of having a daytime job, right? Not complaining though. All right, so this is where we create a new texture. Load cube textures or load texture. I think load texture might be. Yeah, this is where we actually kick off a job for loading a texture. So we're probably going to wind up doing the same thing, right? Because basically what this does is it says, okay, well, here's the resource name that we're loading, the texture that we're pointing to, the image resource that we've loaded, the current generation of the texture, and then a temp texture to sort of write into, right? And we provide all these things to texture load job start. Let's see. So we load into a temporary texture. Which looks like it basically just does a... let's see. This is where the resource load actually happens, right? So I'm thinking we basically are going to write a... Pop. Awesome. You used the TTS there. That was so quick I almost missed it. Thank you for the tier 1 resubscription. I appreciate that. Let's see. How to get your level of mastery from a noob. There's a recipe for everything out there but this. It's all vague on how to get there. So we're really quickly, it's the thing I can recommend the most is two things, actually. Learn how to be resourceful in terms of finding answers on things, and learning what to Google for, right? But also write as much code as possible, right? Just write code all the time. And understand what you're writing. Don't get sort of caught in this tutorial loop where you're just kind of copy and pasting code, because you don't learn anything that way. So if you're going to follow a tutorial, that's fine, but understand what that tutorial is doing and understand what each and every line of code does, and then break away from that as soon as you can, and just keep writing code, expand on it yourself. And eventually you'll get there after you do it enough, right? There's no shortcut. There's no way to go around it, only through it. Let's see. I had a question. Which terminal are you using in Windows? I was trying to set up NeoVim yesterday, and when TreeSitter was trying to compile with Clang, it could not find stdlib. I can't for my life figure it out. Only using the x64 built-in tool terminal thing. Did you have to deal with this? So, I guess that's a double-faceted question, because Windows is weird with this, right? But my actual terminal emulator itself is Westerm. And then I'm using PowerShell. Yeah, there you go. If a tutorial teaches you a hello triangle, I say make it a cube. That's a good... well, I would say start by making a quad, right? Which would be two triangles put together. And then make that a cube, right? And then figure out how to transform it in a scene and so forth, right? Just keep building on top of it. Yeah, there are authoritative docs out there, so if you're stuck, read them. Yeah, that's a very important thing too. So like if you're trying to read Vulkan, read the Vulkan spec, and not just once, but repeatedly, right? Bez, first time chat, lol, welcome. Have you tried fuzzy search in NeoVim? So I have I have this guy. It's Telescope, right? Which is pretty sweet. So yes, it is a fuzzy search. Yep. Greetings from Germany. Hello. First time watching live. Welcome. Writing my own rendering engine myself, C++-ish. I assume that means C++ Lite or C-like C++. OpenGL/Vulkan for Win and Android, so your streams are often helpful. Awesome. I'm glad to hear that. And welcome. I appreciate the feedback. Thank you for that. I'll try Westerm. Yeah, the reason I like Westerm, it's a really good and fast terminal emulator. Pull it up real quick. I'll pull up the website for it. Yeah, and it's GPU powered. It's GPU accelerated, I should say, right? So I'll just drop a link in both chats so you guys can check that out. I'm not like sponsored by them or anything, or it's really just him, right? It's Wes is the guy that's developing it, but he's also a super cool dude. He's very open to ideas and things like that, right? So, all right, and Lua configuration. That's true. Yep. You broke your head trying to get different things. Broke your head yesterday trying different things to get TreeSitter to compile. Yeah. I haven't, I'll admit I'm in an older version of TreeSitter because like once I get my NeoVim working, I don't touch the configuration, right? I don't update it ever because like plugins and stuff as they update and NeoVim itself as you update it, like compatibility between stuff breaks. And I'm like, well, if it works, why would I update it, right? So... All right. Oh, Retro, you're in Germany as well? Awesome. Yeah, you guys, I think, are what? 6 hours ahead of me probably, right? I'm Eastern Standard Time. All right. So I think it probably makes sense to write our own sort of job callback for this. That's essentially going to be mostly the same as this, except it's just going to load one texture in one layer, which we might actually be able to transform this job to eventually just do that for everything. But before I jump into that, I think I'm just going to separate them so I don't break anything, right? So I'm going to, let's see. So this loads the resource, essentially copies all of the all of the properties over, copies of the name, stuff like that. Makes a copy of the load params to fire off as the result. And then over on the job success, which is back on the main thread, we go ahead and pass this off to the renderer to create the texture. Okay, and then we destroy the old texture, update the generation, and then clean up the data. So I think we're going to follow the same pattern for this. That makes the most sense to me. And I think we also... Why do we wait so late to unload the image resource, though, is my question. I guess because we need the data from it. Yeah, right here. I don't know if I want to leave all those resources open until the last minute, right? Maybe we pass our already allocated memory as part of the parameters, and we just jam the data in there as part of the multi-threaded operation. And then now I should think about this too, because do I want to do that on a one thread, or do I want to separate that into multiple jobs? I don't think I can do that yet because we don't have the capability of job dependencies. So I am going to have to do all of the texture loads on one thread, which is not ideal. That might actually slow down loading time, believe it or not. Which is unfortunate. But I think once we get to our other to-do item to have job dependencies, we can resolve that. So it's going to be a temporary slowdown on loading, I guess. Let's see. Oh, that's right, Ivokai. I forgot you're in Germany too. Yeah. Why Windows not Arch Linux? Just because I haven't switched back to it yet. I actually broke my Arch install this morning. I tried to update, and I had some packages that weren't quite compatible with stuff I had installed, so I'm not able to stream there. But I do have my streaming PC, or my streaming machine, I should say, is now the Mac, not the main machine. So I could technically reboot into Linux now if I wanted to. I'm not going to do that just because I know it's broken, but we probably are going to be switching back to Linux pretty soon here. Okay. Cons3D, hello. I have a question in my mind for quite a long time. Why pure C and not C++? A couple reasons. So C is a much simpler language, right? C++ has become quite bloated and complex, unnecessarily, I think. And I'm just not a fan of the direction it's going, right? I don't like all the bits where it tries to manage your memory for you. Like if I wanted my memory managed for me, I would use a language that specializes in that, like C# or something, right? If I'm using C++ or C, it's because I want to control the memory, not because I want it to be controlled for me. C also, because it's a much simpler language, compiles a hell of a lot faster, right? So that's a big time saver, considering how many times you have to compile your code as you're developing something, especially a project of this size, right? And so yeah, C++ has some advantages over C, maybe, but we also don't really heavily use object-oriented programming here, which is one of the main benefits that C++ adds. I don't really use it, right? So I don't need that stuff. There's not really any features that C offers or C++ offers that I need, right? So it's mostly preference, but there are some technical reasons behind it as well. So yeah, I hope that answers it for you. While you're right, you are closer to bare metal, which is the simplicity in question. Yeah, so it's simplicity, language simplicity, not necessarily syntactical simplicity, right? But I have a lot more control over what's happening, right? Hello, started the series a few days ago. Super helpful. I just started learning Vulkan. First time watching live. Awesome. Well, welcome. I appreciate that. Glad to have you here. All right. So I think we're probably going to rework this a little bit. So I think what I'm going to do is I'm going to actually take a copy of this. And I guess let's do right below this. Layered texture job callbacks. All right, and I'll just paste this in here, and we'll rename this texture load layered job start is what we'll call that. We are also going to use different params. So I think we defined this towards the top of the file. We did. So we can actually cheat on this one a little bit. So what we can do, and actually we might actually be able to, you know what? We could move the query technically to this thread as well, in theory. Power Blast, thank you for the follow. I appreciate that. Welcome. Should I move the query? It's not that much overhead. I'm not going to worry about it yet. So let's call this texture load layered params. Load layered params. And the reason this has got to be a different structure is because we have a different number of resources here, right? So we have U32 resource count. And then we're going to wind up with a double pointer here for resource names, because it's going to be multiple resource names that we pass out. There's going to be, let's see, a temp texture and out texture, current generation. That makes sense. Okay. And then image resource. Why are we passing the image resource? I think we're using that as part of the results. We don't actually want to do that. And I'm not even thinking we need the temp texture. I'm going to try and eliminate that, actually. And instead, we are going to include a U8. Let's call this data block. All right, so resource counts. Maybe we'll call this layer count so it's more explicit as to what that is. Layer counts. Let's call this layer names. Right, so basically we're going to allocate this whole block, and we're just going to pass that around so that we don't have to pass the resources around or wait to unload those or anything. We could do that all in one spot. Okay, current generation. I'm not 100% sure we're going to need that either. But I think the temp texture, I think we can actually keep that within the job itself. I don't think we actually need to hold on to that. So I think that's good to go. All right. So let's see. Thanks for the answer. Well, I can't say I agree with you. I'd say you don't have to use memory management features in C++ provides for you, but I see your point. Yeah, you don't have to use them, right? But that's not the only reason, right? It's just that C++ doesn't really offer anything that I need or use. That's really the biggest reason, right? The automatic memory management stuff is I would never use it anyways. I never have as part of my C++ code, right? There are a couple of things that maybe would be nice to have once in a while, but it's not worth me switching to C++ for it. Simplicity for CPU versus simplicity for the developer it is, I'd say. Yes and no. I'm not a huge fan of not having control over what's going on in the code, right? So like, I don't use the standard template library, for example, right? Which is another thing that a lot of people use with C++. I don't use that. because I want to have control over how, again, my memory is managed, right? Again, it's mostly preference, but there are reasons, and I just realized we have ads. So I'm about 30 seconds late on that. But over on the Twitch side, every 30 minutes we are served ads for 90 seconds. So I'd like to pause this stream so that nobody misses anything over on the Twitch side, right? So some people get ads, some people don't. Some people only get like 30 seconds, right? But I like to take that lowest common denominator and sort of say, let's just pause the stream so that nobody misses anything. So with that, we got about 30 seconds left, and I'm going to take this chance to hydrate. Thank you for the hydrate, Redeem. All right, ads are almost dead. All right, ads are dead. Cool. So, you love to use unique pointer and shared pointer. Makes things easy once you know how they work under the hood. Yep, it does. Again, I used manual allocators here, right? Or custom allocators. So that's my reason for not doing that. Particularly when we port code to different platforms, that's going to be paramount as to how we manage that stuff, right? Of course, I love constant expressions, constant evals to do the work already at compile time. So that is one thing. That is one thing that would be useful, and I may have a use for that eventually. I have a couple things in mind that would be super useful for, like compile time string hashing. But yeah, for right now, I don't really need it, so I'm not using it, right? And there's nothing also to stop me from saying, well, the core is written in C, but maybe I have a plugin that's written in C++ if I have to go that way, right? Okay, so layered. So we basically be doing the query here, and then saying texture load layered params. Let's see. And so at this point, we basically have to load all of our resources and jam them into the appropriate spot in memory. Because our resource loading is going to be in order. So the order that the layers are defined is the order that they're going to be loaded into the 2D array texture. So at this point, we basically are going to wind up looping all of this stuff. So we'll do for U32. Do we already have? Yeah, let's call this L. You know what? I'm going to call it layer because L looks too similar to I. So layer is less than load params layer count plus layer. Let's see. Okay, so we do. I'm going to say, well, we're going to handle this a little bit differently, but I'm basically going to do this, right? And then result. Let's call this resource result because we want to split this stuff out. And then load params is going to be layer names sublayer. And an image resource, which we don't have yet, right? So we're going to need an image resource. So we're going to say resource image resource. And it's not from the load params anymore. It's just a local variable. Actually, we don't even need to do this. Let's just check this in line. Let me get this out of the way. So if we fail here, let's go ahead and I don't necessarily want to write something out, but maybe we have a like a result error code or something that we then parse. The reason I don't want to write this out is because we are in a different thread, and if we start logging to the console different threads at the same time, we're going to have collisions there, and our log is going to be really weird, right? Because our logger is not multi-threaded / thread safe yet. So to get around that, I think I'm going to go ahead and create a new structure here for result. So we'll say typedef struct texture load layered result. And this is going to contain actually most of this stuff, but not all of it. So we need the layer counts, current generation, that'll be a pass-through. We need texture and data block, which actually makes me think now we probably shouldn't even pass the data block in. We should probably just go ahead and allocate it in line and treat it as part of the result. Right, and then after this we can do, I'll just say U32 result code, right? And we'll sort of translate that afterwards. So we'll say texture load layered result. Let's see. Range for loops are also nice. Yeah, but I could do the same thing with a macro if I wanted to, technically. I could macro it. Kind of. It's not 100% the same thing. Let's see. What type of code editor do you use to make this? So I'm working in NeoVim right now. And actually, if you're curious about my NeoVim setup, I'll go ahead and drop a link in chat for that. There you go. I'll do that over here on this side as well. All right. Yeah, it depends on the person / developer you are. I find C more simple. C++, I have no clue how some features work at all. For C, I do, but at the end of the day, you can do inline assembly in both. Yeah, so, well, I mean, it's not really that issue for me. Like, I've used C++ a lot over the years. I'd used it enough to know that I like C better, right? It's not, so for me, it doesn't come from a place of not knowing C++. Although, admittedly, the latest revision or two I haven't really kept up with because I don't use it. But I can't imagine it would be that hard to pick up, right? There's also the fact that C is way easier to interop with other language. So by programming your engine in C, you stay the most compatible. So yeah, that's a big thing because you don't have the garbling that happens, or the mangling, I think they call it, to all your symbols, right? Which, yes, there is a way around that as well in C++, but I don't have to do that everywhere because it's just a C engine, right? You're the kind of developer that enjoys writing as short as code as possible. So you're totally a fan of high-level languages like C++ and C#, though I've also started with C and ASM. It really depends on what you're doing, right? Like, if I'm just writing a utility to do something quick, like sometimes I won't use C at all. Like, I've actually used JavaScript and Node for like some quick desktop scripts, right? I'm not opposed to it. It's just use the right tool for the right job, right? I use this because it's what I'm most comfortable with, and it's performant, right? And it allows me to do what I want and need to do. If I can't fit the method function in one screen, that makes me frustrated. Or did you mean to type rustrated? Was that an accident, or was that a Rust plug there? Languages are just tools, 100%. Yep. So there is no one best language, right? I make jokes about using C++ and all that stuff, but at the end of the day, use the tool appropriate for the job, right? So let's see. At what episode does the switch from VS Code to NeoVim happen? I think it was like episode like 108. I think somewhere around there, 107, 108, I think. I'd have to look it up to be sure. Are you going to add more rendering APIs, or will the engine just be Vulkan? We are going to add more rendering APIs for sure. So our Vulkan renderer right now is just a plugin, right? It's its own freestanding library. So it's a plugin to the engine. The engine knows nothing about what rendering backend we're using. The engine just has a rendering front end. And then the back end of that, which is the render specific API, that's all left to whatever plugin you're using. So right now we only have a Vulkan plugin, but I designed it this way so that eventually I can make a Direct 3D plugin and a Metal plugin for macOS. Maybe OpenGL one day. Maybe not. I don't know if that's worth doing. We'll see about that one, right? But yeah, we've designed this in sort of with a modular organization in mind. And actually, I might also be splitting out the platform layer into plugins as well sometime soon. But we'll see how that goes. C++ can be simple too. I'm currently also trying to get familiar with more modern stuff because I have to deal with that kind of stuff, that code on a daily basis. See, that makes more sense, right? Like if you're dealing with it every day, totally makes sense to do that. Like I have to use Typescript for my day job, right? But it is what it is, right? Doesn't mean I have to like it, but it is what it is, right? So yeah, if I were in that situation, I would certainly, be keeping up to date with C++. And I might write some plugins for this in C++ just for the heck of it, right? But I don't have a need at the moment, frankly. All right, so our texture layer result, it's going to need the layer count for when we go to create the texture. The block of data, the current generation of the texture, and result code. I think that's all I'm going to need. All right, and so down here, we have something called result, which was just, let's see, where was that, actually? We have result data. The result is just the Boolean. Okay, so result data is here. So our result data is going to be how do I want to do this? Let's do texture load result, right? Layered result. And we're going to say typed result equals result data, right? Jacob, thank you for the follow. I appreciate it, and welcome. Yeah, unfortunately I just answered this question, Riley, but yeah, why did I choose C instead of C++? Has quite a few bonuses like classes, which I don't use, right? I don't use OOP, so that's like the biggest reason, but C is a much simpler, lightweight language, and C++ doesn't offer features I need, is the short answer, right? So I just don't use it. It's a matter of preference, but it's also, there's some technical reasons as well. For one thing, it compiles faster, right? See, I use structs most of the time when writing C++. OOP is mostly avoided. Yeah, exactly. And it's like, well, if I'm doing that, then like part of the part of C++'s thing is, automatic destructors and things like that, which is great, and automatic constructors. But again, it's more of an OOP thing, right? I just don't need, I don't see the need for that stuff, right? I don't use it. You can have functions in structs. So yes, but not the same way that you can in C++. C++ is sort of emulating it though. So you can have function pointers in structs, right? And then you have to set that and then pass an instance along with it if you need that, an instance, right? A pointer to a struct essentially. So there are ways to emulate it in C, but C is not really for that. If you want to program in that style, then you should be using C++. But I don't do that, so yeah. Because C doesn't have, for example, a this pointer, right? That doesn't exist in C because classes aren't a thing in C. All right, so if this fails, I guess let's actually do one more thing. We should probably make like some error codes, right? My dog is barking in the background. So maybe instead of a result code, maybe we have typedef enum. Let's do texture load result. Load. Let's do load job result. And then we can just kind of add error codes to this as we need. Right, so the first one that we're going to have is like texture load job result resource load failed. And what this will allow us to do is on the main thread, once we get back to the main thread, we'll have some sort of idea as to why the job failed. Oops. So this is going to be texture load job result. Maybe we should call that code. All right, code. And let's do code. That makes a little bit more sense. Okay. So in this case, we can do typed data, or typed result rather. Result code equals result code. Really? IntelliSense? Texture load job code resource failed. Let's see. So if that failed to load, we shouldn't have a resource. So actually, we're safe to go ahead and return false here. You just boot out right away. Because we're basically going to release the resource within this loop for each resource. So if we get to this point, that will be fine. Although we should probably also do a cleanup pass before we return. So let's modify one more thing. Let's say a B8 overall result. And we are actually going to default this to false. No, we'll default it to true. That's fine. So I guess what we can do here is just set overall result equals false, and then break. And that can allow us to do some stuff down here, right? Like release this memory that we need to allocate. So let's go ahead actually, and we'll allocate this memory here on this thread. I think it's perfectly fine to do that. So we'll say result data. Whoops, I need typed data. Typed result rather. Data block equals kallocate. We are going to need some additional parameters in here. So we have our layer names. Well, actually, if I move the query to here, we don't need to do that either. Let me do that. So let's see, where was that? Here. where we are doing this bit. We can do this check here, but I think I'm going to move this query off to the thread, right? Let's see. Process texture reference. I think that's fine to do there. Maybe we should wait to do that until it loads. So let's grab this. And go to the layered job. And we'll go ahead right after this and we'll do the query right away. So we'll query the dimensions of the first image. And so this is actually going to be load params. Layer names. Sub-0, right? So by the time we get to here, this job won't even be kicked off if there's not at least one. So we grab that. Then we have the dimensions. We can figure out how much memory we need. We have the image block here, which I'm going to change to be this guy. Then I can get rid of these two. Let's also take this and put it here. And we'll need to add a new code. So a peak definition on this guy. And we'll add a new one ahead of it. So texture, load. We'll just change this to first query failed. All right, and we'll use that code as well. So we'll do this. We'll paste this here. Take this error. And do we have a result for this yet? Or a job fail? We don't. So let me just do a paste here. Let's see. All right. I also have to use Typescript. Not a big fan. I remember following your series on Typescript Game Engine about 2 to 3 years ago. I remember you using it in Visual Studio. Yeah, exactly. That was before I got comfortable with using VS Code because it was still pretty new at that point. And actually, believe it or not, I think that series was more like 5 years ago. It's pretty old at this point. Yeah. But I did start that one with Visual Studio, and then I moved away from that like mid-series. Let's see. What plugin did you just use for that? What that do you mean? Which thing did I do that you're wondering about? Delibellis rather. Do I use any external libraries like GLFW for making the window? Nope. We rolled all that stuff from scratch. So we implement, all the platform code is implemented using the platform APIs. So there's one for Windows, one for Mac, and one for Linux. Currently. That's going to expand. Okay, so I basically need a copy of this guy. Put him here. Let's move this guy up. And we'll say texture load layered job fail. And the params here, that should technically be result, not params. All right, that should be result data. So that variable is named wrong. And then we can take a look at that and say switch typed results result code. and we can see why we failed. So we can say case, and then we can say resource load failed, or a case texture load job first query failed, right? And we can start filling these things out. Right, and we'll also do a default just in case we forget. And here we'll say k-error layered texture load failed for an unknown reason. And so we can take this line and let's see, this is the failed to load texture. Actually, that's generic. I'm going to get rid of that one. And move this guy to this one. And then here, layered texture load failed to load one or more resources. Whoops. Right. And then image resource system unload. I don't actually need to do that. Right, so basically the result of this, the failure result, is basically just going to look at our result code and then output something to the console. The plugin I used is Vim. That's hilarious. Let's see. Yeah, I don't see a clarification on there. Deli Bellis, if you clarify what plugin you're asking about, I can clarify. Windows API is a bit confusing to me. It's a bit confusing for everybody, to be fair. Do you know any resources to use when wanting to make a window? There are lots of them out there, actually. I mean, there's if you actually just Google for how to open a window in Win32 API, C++ or whatever, you'll find something, right? There's tons of stuff out there. My stuff is based on code that I wrote a long time ago that I've just kind of used over and over throughout the years. So I don't remember where I initially found it, but I know there's tons of resources out there on how to actually do it. So yeah, if you look up specifically how to open a window in Win32, you should be able to find something. And then the other thing that you'll want to do is just all the function names that come up, you'll want to look those up, Google those individually, see what all the parameters are so you know how to actually configure it, right? Because there's a decent amount that you have to do there, right? It's not terrible, but there is a reasonable amount of stuff there. All right. So if the overall result is false at this point, actually at this point we could actually just return. We could actually return out of this, right? We don't have to free anything here because we haven't allocated any memory, so we can just return false. Okay, so everything after this is going to be a little bit different in terms of how it handles it, right? So we have layer size, which is here, and then layer count is going to be load params layer count. So we allocate our data block image resource params. That should be the same. We can use the same parameters for each one because that's just configuration minus the actual name of the layer, so that should be fine. Okay. So if this fails, instead of breaking here, we should probably actually go to like a cleanup, right? But first we have ads. So for those of you who are new to the channel, one of the things we like to do here is pause whenever ads come up. So I know YouTube side works a little bit differently, but over on the Twitch side, we're served with 90 seconds of ads every 30 minutes. So I like to pause the stream for that because it is a programming stream. And, if you guys can't hear what I'm saying or see what I'm doing on the screen, that's not great, right? So we just like to do that so that nobody misses any content. MSDN stuff is actually quite helpful for this. You still have the option to look at the code of libs like SDL. Yep, exactly. Also, Unreal Engine has a pretty decent implementation of it under the hood too. Or at least they used to. I don't know if Unreal 5 does. Or if they resorted to using library. I'm not sure. But yeah, looking at examples is always a good way to go as well. All right, so we got about 20 seconds left on ads, and then we can continue on. UE5 still uses 132. I wondered about that. Yeah, I haven't actually looked at it. The last time I looked at Unreal's code was UE4. All right, and I believe ads are dead. Cool. So, instead of breaking out here and doing overall result, I think instead of doing that, let's get rid of this, actually. I'm going to do this a little bit differently. And I'm going to take U32 layer and define it here. And the reason I'm doing that is to figure out how far into the loop that we got, right? When we fail. And then down here, I'm going to do a label, right? So I'm going to say texture load layered failed. I can't spell failed, apparently. I fail at spelling failed. And what this is basically going to do is if we get to this point, we're going to return false because it failed for some reason. And then we're also going to do a loop. So u32i equals 0. And then I is less than layer plus I. And essentially what we'll do is, actually, do we even need to do this? Is there anything to clean up besides just this block of memory? Aside from the copy of the names, maybe. Yeah, that's probably what we should clean up. Yeah, it's just going to be freeing strings. Okay, that's fine. All right, so we'll do... Oh, wait a minute. We don't need a copy of the name. Actually, we don't have to do anything down here. Okay, sweet. The only thing we need to do is free this. All right, so the way we're going to handle this is we're going to call kFree. Oops. Right, and then that's the size and that's the memory tag. All right. So if we do that, we should be fine. And then here we'll do return true as the result. All right. And then so what we can do is up here, if we have a failure like this, we can do go to failed. And this will keep us from having to type this over and over and over again, right? We could just jump straight to here, that's all that is in assembly, right? A go to is just a jump to a spot in code, and we can free that, right? I suppose we should probably just check to make sure that typed result data block exists. We could be a little safer about it, right? Otherwise, if we get through the loop successfully, we just return true. So we go ahead and load each resource. That gives us the image resource for the current data. So this is going to be, instead of load params, this is just going to be this guy. So we're just doing basically a cold cast there. And then let's see, we're loading into a temporary texture. Let me refresh my memory on why we were doing that, actually. Oh, yes. So we load a temporary texture because the current texture might still be used, right? So if we're actually updating or reloading a texture, we don't want to affect the current texture in memory while it's still actually being used. So that's what that's about. So we don't have a temp texture per se. So we're actually going to need to create that. So let's see. I think temp texture. So it's literally just an empty texture. Okay. I'm just going to do the same thing. So I'll go up here. And I'll put a comment in there so I don't have to refresh my memory. A temporary texture to load into. So that if an existing texture is being used, we don't trash memory that's currently in use for a draw, etc. Okay, so we don't need this. Texture. Alright, so we just create one inline there. I'm not sure if we have to create that on our result or not. We'll have to figure that out. Let's see. Max, hello. Welcome. Molly Rocket's Handmade Hero is a great series if you want to see how Win32 works. Yeah, that's also, yeah, he does have a pretty good introduction on that. Especially early on in the series. Yep. Consider zeroing the freed pointer. Oh, you mean like down when we're failing? Like this guy? Yeah, I mean we could. Right? I could just do typed result. Data block equals 0. We do that in a lot of places. I didn't really bother here because we call a completely different function if this fails, right? So we're not even going to look at that in that function if it fails. So yes, technically that's a little bit more safe. I didn't really do it in this case because it doesn't matter, right? It calls a function that doesn't even look at that. If understanding and control is not the main goals, you should also use easy abstraction layers like header-only solo libraries. There's one that abstracts the platform part. Yeah, exactly. So it depends on what you need, right? Again, right tool for the right job. In a previous stream, you mentioned that you would like to make a couple of game projects with Kohi. Any idea what type, genre of games you would be making? Yes, but I don't want to let the cat out of the bag yet. But yes, I've already got some plans for a couple of games. I'm solidifying some things on it, but yeah, I do have an idea of a few games that are going to test out the features, for the most part, that we've already implemented. You can make k-free the macro that will set the first argument to 0. What do you mean by that? Do you mean like just make k-free to automatically like set it to 0 as well? I mean, I could do that. Yeah, I see what you mean. Like after you free it, set it to 0. I could make a macro for that. I suppose I could do that. Yeah, it's not something that is usually a big deal. Like if it's something I need zeroed out, is zeroed out. If I don't need it zeroed out, I usually don't bother. I just like the idea of coding most of it myself, which is why I don't want to use a lot of external libraries. Exactly. Yep, you have control over it that way. You're not beholden to anybody else. Would it be easiest to start on the game now and add engine features as you need them? So to an extent, but we're bootstrapping some systems here that pretty much any game that we make is going to need, right? So we are going to be starting to make a game sometime soon, definitely this year, using the engine, just to sort of put it through its tests, right, and figure out all that stuff. But yeah, as we develop the game, obviously we're going to discover bugs and discover features that we forgot to add that we need to add and things like that. So we are going to, the entire idea behind making a game with this is to make sure that it works for developing games, right? You can't test it otherwise. Yes, but it may help avoid it to double fraying. Yeah, that's true. Yeah. Although again, in this case, this logic is pretty tight, so I'm not too worried about that in terms of how this works, because the job system works a very specific way with the way that it passes its data around. So yes, you're not wrong though. All right, so we cold cast this. We don't need. We don't need this load params for this. That's just temp texture. So we set the width. Before we do any of that, though, one requirement of this, if we recall, and that's the reason we do this query up here, is to make sure that the dimensions match. So before we actually do any of this, before we perform any further logic, right after we load the resource here, we need to verify that its dimensions match, right? Match that of the first layer's texture. So we can basically just say if resource data width is not equal to first width, or resource data height is not equal to first height, then we have an error, right? So typed result code equals, and we're going to need to define a new one of these. Let's put it so this is going to be resource dimension mismatch, right? So we're going to say resource dimension mismatch. There we go. And we're also going to do this. And we're also going to clean up the resource. So we'll say resource system release, or was it unload? I forget. Unload. And we want the address of image resource. Right, so we'll make sure to unload that so that we're not leaking any of that memory. And then we'll jump down to the load failed, right? All right, so we'll load, copy all the properties over to the temporary texture. Now this is actually going to be, we're going to synchronize the current generation to the out texture generation. So I guess that's fine, because if we fail, we're not going to look at it. So that's fine. This, however, probably shouldn't be done, because if this is a reload and the reload fails, we still want to be able to actually use the original texture. So maybe we should wait to actually do all of this until afterward. Right. Let's see, resource data MIP levels. that's going to be the only one I have to figure out how I'm going to handle. We'll come back to that. All right. So total size is the temp texture width, height, and channel count. So this is actually just going to be layer size. We already have this calculated up here. And that's guaranteed to be true because of the validation that we're doing here on the dimensions, right? So essentially, layer size, right? And channel counts, in this case, the channel count is always going to be, I guess that's fine. So here we're just checking for any transparent pixels. I guess we don't really need to do this. But that allows us to basically check it once to say, hey, does this have any transparency in it? Yes or no. And we can use that for material sorting later on. Let's see. Don't know if you already touched on this previously, but I'm currently going through refactoring the way descriptor sets are created fetched. Is there a standard way to do it? There's kind of a loose standard out there. So generally you group your descriptor sets by frequency of update, right? So for example, you'll have some descriptors that are sort of global in scope that only get updated once a frame, right? And that'll be like your projection and view matrix, for example. And then you'll have a different set of descriptors that get updated per instance of something, like an instance of a material, right? So if you have a wood material and a metal material, you would have one update per those materials, right? And that would include things like your texture maps, and you know, I don't know, your basic like slider type values for your material, right? And then you would have a third set of those, which would be per object, which in our case, we're not actually doing that. We're using push constants instead for that, but you could also have a third of that. So you'd have basically one global descriptor set and then one set of descriptor sets for each instance of the thing that you're working with, and then a descriptor set per object that's drawn in the scene. And then you need to multiply all three of those by how many swap chain images you have, right? So if you're triple buffering, that'd be times 3. If you're double buffering, it'd be times 2. That's probably the most standard way to do it. That's how we've done it here. And I realized actually some of my calculations for that are actually not 100% correct, so I actually have to revisit that at some point too. But yeah, that's the idea. Currently, you go through all the shaders created and pre-spawn the pools per layout. Yeah, which is what you should do. Then use a hash map with a specific hashing to get the correct pool, which is a way to do it. I don't know that I would use a hash map to do that, because having to look that up every time you go to access it would probably be a pain. Seems very verbose, explicit. I'm wondering if I'm missing something. So I would do it. What I do is I tie my descriptor pools per shader, and then I never have to worry about it. Like, it's part of the block of data that I contain that contains all the data along with all the other stuff I need to know about the shader itself, like the the modules and stuff like that. It's contained in that same block. So that way I say, I'm working with this shader. I already know what descriptor pool goes with that shader. I don't have to like look it up anywhere. Because that's going to be a lot faster than looking it up in HashMap, right? Rico, hello. Welcome. Welcome to the stream. Hope you're doing well. You thought about it as a side data thing as opposed to part of the shader. Yeah, so like in this engine, the way I handle it is we have a renderer front-end shader object that contains things like uniform data and stuff like that. That's sort of generic. That is sort of independent of what backend API you're using. And then we have the backend data, which is the render API specific stuff. So for our Vulkan backend, that's where all the Vulkan structures are contained. And it's sort of like an internal shader data that where all that stuff is grouped into a struct in memory. And then that way, it's all very context sensitive as I'm going through my shaders. All right. Where were we? So take a copy of the name. We don't actually need to do that because we don't need the name of each layer. Wait a minute though. So temp texture generation is invalid. That we might need to do. We might need to... Yeah, let's keep that. Let's keep that up here. And actually this stuff doesn't really belong here either. It belongs up here, right? We only really need to set that stuff once. So we invalidate the generation. We don't want to use the resource data width. We want to use this first width, right? So first width. First height. And then I'm going to actually keep hitting the wrong keys. I'm going to set this to 4. Right? And the reason for that is because we're not using one resource for this, we're using multiple resources. And we're going to require a layer channel count. In fact, actually, let me just use that. And then MIP levels. MIP levels we're going to have to calculate. So we're going to come back to this. This based on the first texture's dimensions. All right, so we'll come back to that. So we verify the size, we check for transparency. Let's move this transparency check up here as well. To, I guess let's put it here. And, oh, why is that a B32? I didn't think we were using those anywhere anymore. That should be a B8. So our has transparency is checked for basically until we find a layer that has transparency. So if not has transparency, right? We only want to check this if we haven't run into transparency yet. If at least one layer has it, then we're going to treat it as it has transparency everywhere. So that's that. Take a copy of the name. We don't need to do that. We do need to move this here, right? Because we need to say, hey, if we have transparency, we need to set the temp texture flags. So we'll go ahead and do that. That needs to be done after the loop. This we don't need. And then we also don't need to do that because we're not using the parameters as the result data. We have a separate structure for that. Okay. So we loop through each one of these, check for transparency, and then we need to also insert the pixels into the corresponding layer. So the way that we're going to do this is we have our typed result data block. So we're going to say typed result data block. And we want to calculate basically our starting address, right? So in this case, we're going to have a U8 pointer, and we're going to say offset, right? And then it's going to be the address of, our typed data block, and then plus layer times layer size, right? So for 0, that'll be 0. 1, that'll be a full layer size, right? And it just offsets into that contiguous array of memory. as to where we're going to copy the memory to. And so actually this isn't even offset, right? That's actually the address, right? So let's do data location, I guess we'll call it, right? Because that's the actual address that we're going to copy to. And then we can do k copy memory. The destination is going to be data location. Rick, thank you for the follow. Appreciate that. Our source is going to be resource data, pixels, right? And then Bros, thank you for the follow. I appreciate that. Welcome. And then our size is going to be layer size, right? So that'll copy it into the corresponding layer that we want. Once we're done with that, we need to go ahead and unload the resource, just to make sure that we don't leave that hanging open. All right, so that's basically how we're going to handle our resource loading. I think that makes sense. Okay, so our texture flags, I think all of this stuff is good to go. The only thing is our out texture MIP levels is going to have to be set. I don't know if I actually want to set that here or if I should set that when we get back to the main thread, which is kind of what I'm thinking we should do. All right, let's see. Do you pass Vulkan a file path to a texture, or do you load the texture data yourself and hand that over? So it goes through a couple of layers that we have. So we have a file system abstraction that right now just points to files on disk. And I basically say, give me all the bytes out of this file as just a block of memory, right? And that's what this resource loader essentially does for us, right? So this, when we load a resource, this image resource data, I just called it image to resource, right? All that is just a void pointer, right? It's just a block of memory. And we then take that, and whatever system needs it, we pass that memory off to that system. So for the texture system, that data becomes the pixel data, and so forth, right? So whatever resources it is that we're loading, we'll handle that block of data differently, do some sort of internal cold cast as to what structure it represents. And then we then take that and we ultimately pass that off to Vulkan, right? Which is what we're going to be doing here in just a minute. So basically what I'm doing here is we're loading a series of images, and we're going to treat those as layers, and we're going to input that into a layered texture that we're going to feed back to our renderer, which will ultimately pass it down to Vulkan and do the thing that way, right? Let's see. Intuitively, it seems like I shouldn't load a texture file until my fragment shader actually needs to sample it. So that is definitely not right. You don't want to wait that late, right? And the reason for that is you'd have to hold up the frame while you're loading something from disk. You never want to do that, right? So the way we handle it in this engine is whenever we're dealing with a texture of any kind, we have a default set of textures that we can use to render something in the meantime, while we're actually loading the real texture, and then we swap it out once it's loaded. And the reason you want to do that is because you can actually be running the application and having it do other things versus you don't want to like hold up your rendering frame to load an image because you waited too long, right? Let's see. If you search my name plus descriptor set, you might find it. He wrote a new renderer for his company that supports Vulkan, Metal, and WebGL for mobile. Who's this? I must have missed that in let's see, the function for checking transparency would definitely benefit from SIMD. Absolutely it would. We don't have SIMD yet. Yeah, but you're right, for sure. It's one of those things that's on the to-do list. I just have to get around to it one day, right? Farazmo, thank you for the follow. I appreciate it. And we have ads. So for those of you who are new to the stream, we pause for ads. So on the Twitch side, we are served ads once every 30 minutes for 90 seconds. So I like to just pause the stream so that nobody misses any content. And I'm going to take this opportunity to also hydrate, right? Yeah, there's a lot of things in this engine that would benefit from SIMD. Definitely. Oh, Sebastian Altonen, yeah. Former Unity and Ubisoft engineer, now works for HypeHype. Nice. Okay. Yeah, I'm familiar with him. Yep. I just didn't know who you were referencing specifically. That makes sense. Yeah, so eventually we're going to wind up doing something very similar with this, where we're going to have multiple rendering backends as well. It's just I only work on this part-time, so I can only progress so fast, you know? Can't quite manage to do it full-time. It's not going to pay the bills. All right, so we got about 15 seconds left on ad breaks, and then we can continue. Which, by the way, we're about to hit 900 followers, which is pretty cool. So I appreciate that, guys, very much. On Twitch, should be specific. YouTube is like 12,000 and change. All right, ads are dead. Cool. So let's see. So we need to calculate the MIP levels, which actually is done by the resource loader. So I think what we should probably do, so MIP levels are actually calculated based on the size of the image. Since all of the images have to match, then we'll technically know after we get the first image. We don't get that in our query here. I suppose I could add that. Let's add that here, right? So that way I don't have to like pull it out of the first one and check on every loop, because that seems kind of stupid, right? So let's go back to the image loader. And query properties, we have out channels, and we'll also say U32 pointer out MIP levels, right? And let's see, we have, there we go. So our MIP levels is just right here. So I'm actually just going to copy this because it's the same calculation, right? So once we've actually done the query, which would be here, we can go ahead and do the MIP levels. So instead of resource data, because we're not loading a resource, we can say out MIP levels, dereference that, and then we have that. What am I missing here? Width and height. This is going to have to be out width and dereferenced out height. Right, and then +1, obviously. So we've got that. Let me go over to the header file. U32 out, oops, MIP levels. All right. So now we can actually have U32, oops, MIP levels. So we can query that as well and not have to figure that out on the fly. Why doesn't it like that? Why are you bleating? Oh, did I spell it wrong? Yes, I did. What a dingus. All right. Okay, so MIP levels is there. So technically speaking, you just do this. MIP levels, right? So that's done, which means we also don't need to do this down here. Okay, so we set the flags down here, set the current generation to the out textures generation. Out texture generation, we invalidate which means if it goes to use that texture to render, it will not render it while we are flipping it over to the new texture. I'm not going to do that here. I think I'm going to do that on the result. Current generation, we can take the current generation, but I don't want to do this in validation until we're processing the result, right? So, we don't actually have that yet, so we need to actually, we're just going to take a copy of this guy up here because it's going to be mostly the same process. Right, so right here. And we're going to say this is load layered job success. And take this. And let's just put it here for now. We're going to have to change this up, right? So I'm going to get rid of this so we can see what the heck we're doing. And let's see. Default texture. Yeah, it makes sense. Yep, exactly. Yeah. So that's kind of the way we handle this, right? And this might be a little bit tricky because we actually have a layered texture. So we're not going to have like a default texture with the right amount of layers, I don't think. So we may have some work to do to figure that out. That's actually an interesting problem that I'm going to have to figure out because we don't have a default layered texture, which means if we have a view that is attempting to access like 10 layers, say, but we use our default texture, which only has a single layer, it's probably not going to like that. So that might wind up being a problem. I'll address it if we hit it. Okay, so texture params. This is no longer correct. This is result, technically. And this needs to be load result, layered result, rather. All right. And so the only way that we're going to get here is if we had a positive result. So we don't need to examine the actual result code for this. Speaking of which, we did add one. Before I forget to do that, we did add one here. So we need case, texture, whoops, texture, load, job code. I think it was resource dimension mismatch. We haven't, yeah, okay. Okay, error. So this one basically means that we failed to load the layered image because at least one layer's texture is the wrong size. That's a requirement of layered textures, right? They all have to be the same size. Okay. So let's see. So basically what we do here, we don't have resource data. So we can get rid of that. All of our resources are cleaned up before we get to this point. So this is once the job is done. We have all of the data loaded into our data block. So we need texture params. And then data block. And then, oh, temp texture, that's where we needed that. So the result does need the temp texture. Okay. I was thinking something completely different, but yeah, that makes sense. So load layered results, we're just going to do texture, temp texture. And this is going to be, this should be texture. Actually, let's go with typed params, right? Or typed result. Okay. This will be typed result out texture. So we'll invalidate that. All right. So before I forget to actually change this to take in the temp texture, let's actually change the job itself. I think it was below here. So instead of this temp texture, this should be, let's see, what did I call this? Typed result, I think it was. Yeah, typed result. Typed result, temp texture. So I just need to do the same thing here. Whoops, I cut off the T. That's nice. All right. And then typed result, temp texture flags, and one more here. Okay, I think we got them all. All right, so now that's part of the result that gets passed over here. Oh, this is why we kept the name for the resource name. Let's take a look at typed result. I don't think we actually kept the name. We're going to keep not the individual layer texture names, but the name of the actual sort of combination texture that we're loading, right? Which, does the params have that? Params do not have that. We only have the layer names, right? So we're going to need that here too. Do we need this? Yeah, we do need it. Name. Right? So what we'll do is when we start the job, actually, let me think about this. We should probably take a copy of the string, I'm thinking. So we'll do typed result name equals string duplicate load params name. And we'll just free that on the other side, right, on the result side. So the only way that we actually perform this copy is if we load all this stuff successfully, right? So if we don't have to worry about cleaning this up on a failure, we only have to worry about cleaning it up on a success. So this actually needs to be typed result current generation. Okay, so we take that. All right, and then over here on job success, we can say typed result name. And then immediately after that, we can do string free typed result name. And just to be explicit, we'll zero it out. All right, so we report that it was successfully loaded. We don't need to do this. I guess we should probably check to see if that exists. So if typed result name, then we do this stuff, right? Which I guess this is the same block, whatever. It's fine. Get rid of that. Get rid of that. And then, of course, we actually have the texture pixels themselves, which once loaded to the GPU, I guess we don't really have to hold on to. Let's see. Vlad, no clip. Thank you for the follow. I appreciate that. Welcome. Hope you're doing all right today. All right. So where is the... So I guess after... we get to this point, we can clean up the... We can clean up this guy, right? The results. So we'll say if... Well, I guess if we don't have the data, we're kind of screwed, right? So typed result, data block. All right, and this is going to be k-free. Oh, you know what? We don't have the size to free this, do we? I don't think we copied that over. So we're going to need that. And then mem tag array. Yeah, because I don't think... typed results. We have layer counts. Nope. So I guess I could save off the size, right? I'll say data block size. So we'll add that here. U64 data block size. And then when we load the... We set this up. We'll put here typed result data block size is equal to layer size times load params layer count. And then we can just do typed result data block size. Okay. I think that should be good to go. The only other thing... typed result. I don't think we copied over layer count. Layer count. And then also typed result. Temp texture. Array size is equal to layer count. So if we don't set that, the backend is not going to know what to do with it. Did I not? Oh, that should be load params layer count. Right. Okay. You know what? I'm doing all the typed result copy stuff down to the bottom, so let me just move this one particular one down here. And then we set the array size so that we know how many layers we have. Wait, not layer size, that's not what I want. Layer count. Is it not layer count? Layer size. Layer channel count. Oh, load params layer count. Almost used the wrong thing there. Okay. So that should be good. Our fail is filled out. Our success is filled out. All of this logic should be the same. Successfully loaded. Let's call this layered texture. And I guess if we don't have a name for some reason, let's at least specify that one was loaded, right? And just without the name. Right, so Lenio, thank you for the follow. I appreciate it and welcome. Marsk, hey, how's it going? Cool to catch you live. Caught you at Spiro's yesterday. Yeah, his stream was pretty cool. I really enjoyed what he was working on over there, for sure. Hi, is this NeoVim? Yes, it is. Yeah, so this is what I'll do is I'll go ahead and drop a link to my configuration in there. So that's an article detailing my NeoVim setup, right? I'll drop it over on the YouTube side too. Hopefully my bot is still awake. There it goes. Okay. You're also doing some interesting stuff. Thanks, I appreciate that. Yeah, I find it interesting at least. Yeah, Lenio, no problem. Thank you for being here. I appreciate it. So, oh, I actually just noticed something kind of neat. So, we just hit 900 followers, which is pretty cool. So I appreciate that. Thank you guys for that. Appreciate it. Appreciate each and every one of you guys. That's a heck of a milestone, right? Okay, so now that we have these set up, we can actually go to start hooking up our job and call this thing, right? Let's see, what was that under? Acquire textures as arrayed. And this is kind of what we were doing initially. And what we really need to do is something more akin to this, right? So process texture reference, which actually I think process texture reference is actually what calls the thing that kicks off the job, if I remember correctly. Calls load texture, right? So we need this. Our array size. What do you think about this? So our type is going to wind up being texture type 2D array. And our array size is going to be layer count. And then texture system acquire. This needs to be textures as arrayed. And then all of this goes away. And I think actually we just need to do this actually. So we get an ID. Do we have? Yeah, we have the ID up there. So that should be good to go. So it pretty much works very similar to our other texture loading functions. It's just this allows us to load a arrayed texture, right? So I'm going to, oh, you know what? I think we need to specify if we should auto-release it or not. Yeah, let's go ahead and do that. So we have, here it is. So name, layer count, and layer texture names. We need a B8 auto release. What that basically means is if we are if we release references to the texture and that reference counter becomes 0, then we go ahead and release the resources for the texture. Free that up on the GPU and whatnot. So let's see, which argument was that again? Auto release. Okay, so auto release, and then skip load is actually going to be false. We don't want to skip the load in this case. This comment is invalid, so we'll get rid of that. Okay. So basically what this process texture reference does is it finds a free texture slot in our internal array, utilizes it. The ID is a lookup index into that array, and then we use that to actually return our registered textures. And that's basically how we manage our texture references. So we have a lookup hash table that we use to maintain a counter on that. Every time we get and release a texture, we increment or decrement that counter, and then release accordingly. So down and process texture reference. Let's see. So we have a couple of things here, and actually I probably really need to clean this up, right, and split this up into a couple of different functions. So we're incrementing, check if the handle is new or not, right? If we have a new handle, then we're in this. We are not going to skip load. And then we have the types of the texture here. So we have cube, 2D, and 2D array. Acquire internal texture resources and upload to the GPU. So there's going to be a different... Oh, wait a minute. I wonder... I just realized something. I think there's a bug in this. So when we create a writable arrayed texture, writable arrayed, or writable, because they both basically go through the same path. Oh, we're calling the renderer create here. Okay. That's problematic. So we probably shouldn't be doing this here. We should be doing this here. And we're also... Oh, I guess the rest of this is fine. But we really ought to make all this stuff happen in process texture reference so it's all in one spot, right? We probably shouldn't be doing this here. So we also have a skip load, which is basically, is this going to be loading texture content or not? For writable textures, we typically don't load that. So that's false, right? Which is, true to skip the load, right? So that's true here. So in that case, we should just be basically just calling this directly. But we're not actually doing that, which is wrong. So what we should be doing is in there, if we are skipping that, we should be doing this. If it's a writable texture. But I don't think texture process reference takes in whether or not it's writable, which is probably why we didn't do that. So we have a skip load, but we don't have an alt texture ID, but we don't actually take in the texture or anything like that. So we actually need to address this a little bit. So we have a skip load, but we don't have like a writable versus not writable, which makes a difference when we create the texture. So this should take another Boolean here. I'm already not a fan of this many Booleans. I might convert this to a flags something. We have adds, So I will pause while ads are running. That way you guys don't miss any content. So for those of you who are new to the stream, we pause the stream every half an hour for 90 seconds, because on the Twitch side of things, that's when ads are served. Can't avoid them, so we gotta just pause the stream, right? Because the people on that side cannot see or hear what I'm saying if they're being served ads. So we just take a minute to pause those, and then I can hydrate. So we got about 40 seconds left, and we can get back to it. I probably ought to see about like implementing a timer or something on this screen so that you guys can see how far we have to go on ads. I'm gonna write that down, actually. I just now thought of that. Got a little over 10 seconds to go, and then jump back in. All right. And I think ads are dead, so that's cool. All right, so what we're going to do here is we're going to add another Boolean, right? And we're going to call this one is writable. So we'll do that, and then we'll also do this for the declaration at the top. Is writable, right? And we'll have to modify all the places that call this to pass that appropriately. But basically, in this case, this is going to be true, and everywhere else it's going to be false. So then we can take, let's see, I'm going to take this return and just paste it down here, delete that, and then grab all of this and go to here. And if we are skipping load, let's see, so skip load, right? And then if is writable, then this is what we want to do, right? So we'll do this instead. That's how we'll get our texture handle. Some of these things we might actually have to set further up, because I don't think we actually pass that stuff in here, do we? No. So I guess some of this stuff has to be done up there. Like the width, height, channel count, that kind of stuff. Array size, we pass that in, I think. Yes, we do. Okay. Has transparency. Texture flag has transparency. So if we have... I guess we need to set that one as well. So most of what we're going to have to do, actually, is... do we set the ID... Yeah, we set it here, but that's in the skip load, so we actually need to do that in here somewhere. So let's do... Oh wait, we don't actually even need this because we already have it up here. So get rid of that. The texture ID is set here to ref handle. We already have a ref handle, so technically that should be done in either case. right? So let's take that and put it here. And we don't need to do that here. The type is already set. The name is also copied. I think we also do that down here somewhere. So we'll do this either way, whether it's writable or not. The array size is already set. The generation is invalid ID to start. I think we also do that in load texture, I believe, but since we're not loading a texture, that's fine. So let's actually just default that. MIP levels, if it's writable, is gonna say always 1. Do we take in that? I don't think we do. We might eventually want to take that in, but for now I'm just gonna say it's 1 if it's a writable texture. Okay. And then we will also set the internal data. We'll 0 that out by default. So really the only thing that we have to do further up is this guy, because that's passed in. Okay, so so for this guy, we have the has transparency is passed here. So texture t equals this. Right? So we basically just have to set a flag after this is done, which I'm fine with. Okay, so that's good. So essentially, no matter what we do these things, we probably ought to grab some more stuff from down here, although I guess this is a little bit more different, right? So we have name. Load texture, I guess, takes care of some of that. Okay. So if is writable, then we do that. Otherwise, if we are creating just a regular texture that is not writable, we need to do this. And basically what this does is creates a non-writable texture and does not pass any texture data, right? So the memory was reserved, but no data is actually loaded up to it. And that's because we are skipping the load. So typically you'll only skip load for like writable textures, but you may skip load for other purposes. So, okay. Otherwise, if we come down here, we are doing something that we probably shouldn't be doing, where we were basically calling this directly instead of load texture. So let me go to load texture real quick. So this is what kicks off the job, which quite frankly, we just do in line, right? I don't think we actually need to, well, I guess we can say load texture and then load layered texture, which will kick off the other job. All right, so we'll do load layered texture. All right, we'll also duplicate this for now. Layered texture. All right. And then it's basically this same thing, just calling a different function, right? So we'll say load layered texture, failed to load layered texture. You know what, though? I don't like all this repetitiveness. I don't like it at all. Let's modify this actually to take the texture type. So that load texture will basically kick off whatever job should be kicked off instead of having two separate functions. I like that idea better. So peak definition. Oh, wait a minute. The texture type should already be set, right? So we're looking at type here. Texture type is already set, so we don't actually even have to do that. So this actually should be looking at T type. Same thing here. And we can change this to a switch, actually. So we'll do that. Yes, I know those types aren't handled yet. I haven't done them yet. Case texture type 2D and case oops, need a space there. All right. So this guy needs a break. Oops. And then this guy needs a break. And then we can get rid of this. Whoops. Ah, keep hitting the wrong dang keys. That. All right, so our texture type 2D and 2D array will be handled the same. I'm fine with the same error message. I think that's fine. So I guess we had this new load texture or load layered texture. We don't actually need this. Which means we don't need the forward declaration up here either. All right. So, if T type, oh, I think my IntelliSense died. Texture, whoops, equals texture type 2D. Then we do this. Oops. Else if T type equals texture, whoops. Yeah, texture type 2D array. Yep. Looks like my code completion died, so let me let's see. Oh, there it is. It works again. Okay. So texture load layered params. And I'm going to zero this out because I just like to be safe. I'm going to do the same thing up here. Right. And just fill this out and then essentially call a job to do almost the same thing. Check on chat. Mike and the rest, first time chat, hello, welcome. Interestingly, you didn't get any ads on Twitch. Yeah, not everybody does. It varies based on platform, region, and locale, right? So there's always like different ad slots for all of those things. And if there's no ads to fill those slots, then they don't get filled and you guys don't get ads, right? But I have to assume that somebody somewhere is going to get ads, right? So I usually just kind of go based on that, right? I guess you could just return T instead of accessing the array again. Yeah, exactly. I think I had it that way before, and then I switched it, but then realized I had to switch it back. Where was that? I think it was this one. Yeah, I had it that way, and I switched it back. So T. All right. Why not Nos? I appreciate the follow. Thank you. Welcome. Hope you're doing well. All right, so params layer count equals T array size. Params name equals string duplicate texture name. Params layer names. Shoot. I don't have that. All right, we'll come back to that. Params current generation, I do have that, equals T generation. And params out texture equals T. All right, so I guess just to keep like all of this stuff kind of working the same, I can just add some parameters to load texture and then just pass zeros for everywhere that doesn't use it. So I guess that's probably the lowest barrier to entry, right? So we already have the layer count, right? So I guess really all I'd have to pass is the layer names themselves. So layer names. So we can do layer names. Although, wait, what did I do for this? Is that just a... Oh, it's not a constant. Yeah, that's fine. I should probably take a copy of that, though. Right, because I don't want to rely on the life cycle of this layer names, wherever this ultimately comes from. I should take a copy of that block of memory, right? And it's just an array of character pointers that's going to be the size of this, right? So I think I can safely assume that on my memory copy. Because all we're doing is basically copying a list of addresses at that point. So that should be fine. Let me fix this forward declaration first. So character layer names. So yeah, we'll do allocate size of character pointer times t.array size. And this will just be memory tag array. And then we'll do a k copy memory. The destination is going to be params layer names. The source is going to be layer names, and the size is going to be the size of character pointer times t array size. So we'll have a copy of that. Although that's still... I should go through that actually and... No, you know what? I'm not going to do this because that's, again, that's just copying pointers. I don't want to do that. I should duplicate the strings. So for u32i equals 0, I is less than t array size plus I. So we're going to say params layer names sub I equals string duplicate, oops, layer names sub I. What did I, oh, I forgot a semicolon. Okay, so we take a copy of all those layer names. That way we don't have to worry about the life cycle of those strings. And then I guess we're going to have to clean that up in... Should probably clean that up in the job because we don't need them beyond the job, right? So when we do load failed, we need to clean them up either way, actually. So I need to free the strings themselves and then the array. Let's see, I don't want to do that twice. I think I am going to have to do it twice, though. I don't see a way around it. Okay. So for u32i equals 0, I is less than typed results layer count plus I. And then what we'll do is a string free on the load params layer names sub I. And I'm not going to bother setting those to 0 because we're going to nuke the array as soon as we're done. So I'll do a k free load params layer names. The size of this is going to be size of character pointer times load params layer count. And the memory tag is going to be array. Now I can say load params layer names equals 0. Okay. I really don't want to do this cleanup twice, though. Kind of sucks. But I guess I'm going to have to, right? Let's see. What exactly does the terrain look like now? So it's a height map terrain. Unfortunately, I can't run it, right? Because I've kind of got my code broken here. But actually, do I have a screenshot of that on the repo? Let me see. Let me see. I might have a screenshot of it on the PBR branch. I don't remember, though. Yeah. So this is it before we actually implemented PBR, because I actually have to update this screenshot, right? This is just showing it running on different platforms before we actually implemented our PBR Lite pipeline, which is the branch that we're on now. But yeah, this is basically what it looks like. It's your basic height map terrain. This is also before I put in MIP mapping. So that's kind of a little bit obvious here too. It looks much better than this now in terms of its lighting. But yeah, that's basically kind of what it looks like. I can't run it at the moment, like I said, because I have the code torn apart. Have I had any shortcut issues with NeoVim on Windows? No, not really. No, it's worked pretty flawlessly, actually. I use the same configuration file cross-platform with some platform-specific forks in the config itself. But yeah, I'm able to use pretty much the same config across the board, which is nice because no matter what workstation I'm on, everything's the same, which is pretty cool. I do tend to avoid keyboard shortcuts that involve like on Linux it's the super key or the Windows key. I avoid those though, so maybe that's why I don't have any issues. Okay. I hate repeating myself, but I'm gonna do it because I don't feel like figuring this out or thinking about this any further right now. So, hack, dry. Don't repeat yourself. But I'll figure that out. I'll figure that out later and come up with a better way to handle this, right? You had some, but it could have been something on your end. Yeah, that's possible. If you used the Windows key for any of them, that definitely could be problematic. All right. So the only thing left to do is to create the job and submit it. So we want the texture job, or the texture load arrayed, layered rather. Texture load layered job success. Layered job fail. And then our input is texture load layered params and texture load layered result for this one. You know what? That line is kind of obnoxiously long, so I normally kind of hate doing this, but I'm going to split this up to a few lines because that's kind of just ridiculous. Okay. Actually, yeah, okay. Technically, this logic is repeated here and here, but we're passing different function pointers and different size of things, and I don't feel like creating variables for all those things just to eliminate that. So I think that's how I'm going to roll. One other thing I want to do is catch the other case of texture system attempted to load unknown texture type, and I'll output this as a U, an unsigned integer, and I'll put T type and return false. Just so that we know if we try to do that for some reason, that we need to update this. So I'm thinking probably what I'm going to do. Eventually, I think I can combine these two jobs into just one job, and then it doesn't matter. But for now, for the sake of testing, I'm going to keep it this way. All right. Let's see. We are about to hit another ad break here in just a second, so I'm trying to think if there's anything else I need to do. I can take the ad break to actually think, because I feel like let's try to build real quick. See if I missed anything, at least that the compiler catches. Yep, missed a few things. Oh yeah, we got to update the load texture calls. Whoops. And we have ads. So we will break for ads just for a quick 90 seconds. It's actually a little bit less than that now because I caught it a few seconds late. Just so that you guys don't miss any content. And then I can think for a moment on what else I might need to cover, because I don't think I covered this on the rendering backend in terms of loading layered textures. I don't think I've covered that. So I'll have to look at the Vulkan code to see if that case is covered. So we've got about 45 seconds left on our ad break. I think we've done everything. Yeah, I think we've done everything that we need to do in the texture system. Just a few more seconds left on ads, and then we'll be good to go. All right, so ads are dead. So I just have to fix this load texture, and then I don't think we've actually exposed this new function to the rest of the engine yet. I don't think we actually put it in the header file. I think we were actually just kind of building it out in the C file to see what it needed to look like. So, do we have layer names here? We do not. So when we process a texture reference, we are also going to have to take that in. So we have this writable, but we have an array size, right? But we don't actually have anything in here to denote what the layer names are. So we have the layer texture names there. So really what we need is like right here. Layer texture names. Which means we're going to have to update process texture reference again. So we're going to put this after array size this time. So we'll do actually, I don't know if I want this constant or not. Let's just do character array. Layer, actually, yeah, we'll do layer texture names. And then up here, we'll do same thing. Layer texture names. All right, which means that, again, everywhere that we actually call that, we're going to have to update that, right? Too few arguments. We have name, type, array size, texture names. Oh, wait a minute. Our reference diff got pushed out by quite a lot. Okay. So this actually needs to be like here. And then, oops. reference diff, auto release, skip load, and is writable. So in this case, writable is false. All right. Oh, and that's constant. So this should take him as constant too. They are constant on the way in. Okay, so that one is fixed. This needs to be moved here. We're going to pass a null for writable arrayed. So that'll fix that one. And then, let's see, so process texture reference. We have array size of 1. And then we have texture names and then reference diff. So we just need a 0 in between these guys, because we're not passing names. And then we also need false because it's not writable. This one is going to be the same set of changes, actually, because this is texture system acquire. So this needs a 0 here because we're not passing names. And then false because it's not writable. All right. I could probably reduce some of that. I should probably like create a struct or something to make that a little easier to use, but it is internal, so I'm not that worried about it. All right. So when we're loading textures, we can just pass through layer texture names. Oh, and this is, let me guess, not constant, right? It should be. This one up here too. Okay. I think that might be the only place that actually calls that. So I think we might still be good. All right, so let's go to that. Because this we have layer names. Okay, yeah, so we should be good. We're string duplicating that, so that should be fine. Okay. Let's build again. Isn't string format a possible buffer overflow? I mean, yes, theoretically. I probably should include like a max on that at some point, right? Maybe just with a default value or something. But I try to only use it in places where I know like what the size of the actual string is going to be. Okay. Process texture reference. We missed one. 248. Oh, wrap internal. I forgot about this. Okay, so this is 0 for that. I don't remember though if this had to be. Oh, writable is actually passed in. So is writable. Whoops. Dang it. All right. Undo too many times. All right, so is writable. Okay, so that should fix that one. This one is texture system release. So here it doesn't really matter what we pass, right? You just pass garbage here because it doesn't really need to look at these parameters. Process reference. Okay, did I get them all this time? That sounds like the beginning of a tragedy. Yeah, exactly. Yeah, what I'm probably going to do is make it a bit like endcopy, where you have to specify a max length. But ultimately, you know, whoever's using it needs to provide a buffer of the right size. But yeah, I probably should add that. In fact, I might even go put a to-do on it so I don't forget to do it. Or at least if I do, I can yell at myself later. Why is this... Oh, different signs. Okay, 768. This one is a U32. So it just doesn't like the fact that this is a I32. But images, for some reason, can technically return as a negative size. I've never seen it happen. But pretty much any image loading API that I've seen, at least internal ones, allow it for some reason. All right, so at least we build, but let's check the Vulkan side of things, because I don't remember if we actually handled this or not. So we have create writable. And just a regular create, which is the one I'm interested in at the moment. So we do have an array size. Map levels. We write the data. Size and pixels. Maybe it'll just work. All right, I'm going to try and run it real quick. I am highly skeptical as to whether this is going to work because we made a lot of changes and I'm not sure I covered everything. But we'll try. We'll see where we wind up, right? Okay. I'm guessing we foobarred a shader or something. Yep. Let's see. Terrain shader, fragment, unexpected left bracket on line 165. Oh, why did I do that? That's a copy pasta issue. Okay, so I did it wrong in all the places apparently. Okay, let's try that again. All right, I saw some validation errors in there, so we'll have to take a look at those. Atlas issues. Uh-oh. What did we create? Image create info. Width equals 0 is not greater than the... okay. So we're getting a 0 width on stuff. That seems fine. Nope, it's not. 0 empty copies are not allowed. Where is it? Where is it getting... Okay, I'm going to have to trace to see where this is actually getting a 0 width and height. It's probably something where I moved all that code around writable textures. In fact, I'm actually pretty positive that's where it is. So... process texture reference. So if we're creating a new one, which is here, we don't actually have the width and height set. Well, and that's only going to be for I think these guys have. Where are the width and height set actually? Let's take a look at all the different places that call it, right? So this never did it here. Nor did that. Or that. This one, I think. Actually, this one did at one point. Right. Right there. And the problem is this calls texture load, and we haven't passed that information across. Which also means we have to pass these two and this. That's a lot of parameters. I'm not really happy with that. I may need to split up how this works so that I don't have to pass so much stuff. Because the size of this is getting kind of ridiculous, right? So, all right. I think I'm pretty much out of time for today. So what I'm going to do is I'm going to leave myself a big old fat to do here. Need to pass dimensions to process texture reference, but the param count is already high. Split up the ref load question mark. Because I'm thinking if we come in here, like there's only like the load gets kicked off here essentially, or here. And technically speaking, we don't have to do that inside of here. We could just handle like the reference counting aspect of it in here and not kick that off from here, and basically return back to the caller of this, and on success do that. I was just trying to avoid doing that in multiple places, which is why I did it here. So maybe we have like a separate function that somehow does that. Although this is pretty unique, and I think we could use this everywhere else, so we might be able to just do that. I'm going to take some time and think about it, I think. I like that Vulkan gives you understandable feedback about what you did wrong, but does it have to be this cluttered and almost unreadable? Yeah, I know. It's very explicit, right? When sometimes what I do is I actually write all this out to a... why could I not find console log? Did I not get that far? I write this out to a console log file, which for some reason VS Code didn't want to pull up. And sometimes, yeah, I mean, look at this. You can really see all the validation errors here, right? So this is all ultimately fallout from from us not providing dimensions. But yeah, it's very explicit. But it is kind of nice. It gives you like a link to the part in the spec where that's detailed on how it should work. So that is nice. And there's not really mistaking like what exactly the problem is. It's pretty explicit in its error messages. But I do like the fact that they allow you to name stuff too. And they pick up on that. So that is pretty nice. Because without that, it would be impossible to tell just by a memory address what the heck you're looking at. But this is all extent and image extent issues. This is all due to not receiving the right size of texture. So I just need to rethink that internal handling a little bit and come up with something a little cleaner. All right. So with that said, I think what I can do, I guess I'll go ahead and I'll upload this to a branch so that at least you guys have like the work that I've done, because git status. There's a decent amount of work done in here, right? So I'll do this under the PBR. I'll do PBR. Let's call this layered textures. Oops, I forgot the B. We'll add work in progress layered textures. PBR layered textures. Cool. All right, so that's available there on the branch for you guys if you are interested in that and you're following along that closely. It's there. And at least this way, when we go to merge it back into the PBR branch, it'll all be condensed into one single commit so that you can actually see all of that at once instead of sort of split up in a million different commits. All right, so that is pretty much where I'm going to leave it today. I'm going to find somebody to raid, but before I do, I would ask that you guys, if you haven't already, if you follow me here on Twitter or on YouTube, that's a big help in growing the channel, so I'd greatly appreciate it if you did. If not, that's cool too, but yeah, let me see who is online that I could raid. Just gonna pull up the Twitch page, I think. Let's see, who do we have? You know what? I'm gonna raid CM Griffing because I almost never get to raid him. He's raided me a few times. I think I've raided him maybe once or twice, but it looks like he's doing leak code stuff. So I'm going to go ahead and raid him today. So if I can type it out correctly. And yeah, he's always doing pretty interesting stuff on his stream. He's got a web-based dictation tool that he's actually experimenting with, which is also pretty cool. So we are going to raid his channel, and I thank you guys for being here and following along on both sides. And yeah, thank you guys, and I'll see you guys in the next stream. Peace.